Agriculture is the largest user of water. I'd like to begin quite generally and describe the agricultural landscape both globally and within Canada. I'll then describe a possible future for agriculture and what that can mean for water resources, and I'll end with the title of this presentation, A World Without Groundwater, what that could possibly mean for agricultural production. So, why should you care? Of all human activity, agriculture is the largest user of water. But water use has two terms. There's withdrawal and there's consumption. Water withdrawal is the volume of water abstracted first as surface water, either from lakes, rivers, spring discharge, or as groundwater pumped from underground aquifers. Globally, 70% of water withdrawn is used for agriculture, and 90% of water consumed is related to agriculture. These stats are widely different for Canada, but I'll continue with the global landscape and return to Canada in just a moment. So what does agriculture look like on the planet? Of all the ice-free surface, agriculture takes 40%. This 40% is distributed as follows. 30 to 35% is crops. That's my drawing of wheat. Marginal, wineries and horticulture and fruits. And the rest is pasture. What about irrigation? Irrigation is mainly used on crops, very marginally on pasture and permanent crops. My circles get worse, eh? 25% globally is irrigated. 40% with groundwater, and 60% with surface water. I'd like you to be able to leave this presentation with a few facts you can use either at trivia like the other night, or if you're at a party where there's interesting people like water people. Crop, I said, is 35% of all the agricultural land. That's 15 million kilometers square. But that's too large of a volume, or too large of a surface area to think about. So that's the size of Canada, Alaska, and India. So all agriculture fills up and can be put in these three countries plus state. 25% is irrigated. That's as if all the irrigation fills up and can go inside of India. To introduce a Canadian perspective, I'll introduce volumes of water. But once again, I have difficulty with volumes of water because I have difficulty conceptualizing anything beyond 25 gallons or 100 liters. So for some context, an average bathtub is between 100 and 250 liters. But as you're all water-minded folk, you probably haven't taken a bath in quite a while. Elizabeth Dowdwell, she's a Canadian water leader, and very inspirational if you ever had the chance to hear her talk. And she's often introduced as someone that hasn't taken a bath in nearly a decade. So in Canada 2010, we used 800 million cubes of water for agriculture. That was split 50% for crops, 30% for hay, and the rest for pasture, fruits, and vegetables. Now agriculture in Canada is somewhat similar. We have 50% crops, but 30% of our land is used for pasture, and the rest is used for hay, fruits, and vegetables. 2010, however, was a very wet year, with Canada receiving between 85 and 150% of its annual average precipitation. Rewind a bit of a decade, 2001, we used 4.8 billion meters cubed of water. Fast forward to 2007, we used 1.5 billion meters cubed of water. And as I said before, 2010, 0.8 billion meters cubed of water. Between 2007 and 2010, it wasn't only that we had more water in 2010, but less crops were being irrigated. We had 700,000 hectares that were irrigated in 2007, and we had 500,000 hectares that were irrigated in 2010. But I have to put this in the context of agriculture in Canada. 65 million hectares was related to agriculture in 2010. That means less than 1% of Canada's agriculture is irrigated. In the driest of years, around 2.5% of Canada's agriculture is irrigated. Once again, I want you to leave with some facts. We can call them harvested facts from this presentation, using water-wishing terminology. 65 million hectares is actually very close to the size of Alberta. So all of Canada's agriculture can fit in and fill up Alberta. Irrigation, the size of the Calgary region. Irrigation in Canada can fill up the Calgary region. So I said 0.8 billion meters cubed of water was used for agriculture, withdrawn for agriculture. That's 6% of the total water withdrawn in Canada in 2010. So with 6% of the water withdrawn and 1% of agriculture irrigated, I was kind of left troubled because the global picture is 70% of water withdrawn is used for agriculture and 25% of the land is irrigated. So I went to Kim Sturgis after her presentation on Sunday and I said, given these low statistics for Canada compared to the global standpoint, should we really be talking about agriculture when we talk about the future water problems in Canada? She took a moment and then she said, water is a local issue, as we were talking about with Bruce, which is a common theme in the plenary discussion. 60% of irrigation is used in southern Alberta, 30% is used in British Columbia. So perhaps a national statistic is not the best measure of the importance of water and agriculture in Canada. Yes, okay. It also left me actually with another hope, that Canada is at the forefront of a decision to increase agricultural production, increase exportation, become a major player in the global food market. But yet we've yet to intensively use our groundwater. So this is the opportunity, our window of opportunity, to start water dialogue, legislation, regulation, monitoring, enforcing. So before we enter perhaps this dangerous place for our quantity and quality of water, we have the opportunity to protect our resources and not follow in the same footsteps of so many countries before us. So we have an idea of the agricultural landscape, perhaps what could happen in the future of Canada. But back to the punchline, the world without groundwater. So my work for the past several months has been to detail this idea for India, rice and wheat production. How much of rice production is related to groundwater, how much is related to surface water, and how much of it is exclusively precipitation fed. So I have these calculations for rice and wheat in India, but previously global studies have estimated how much production we would lose if we just stopped irrigation altogether. So I'll begin by tiering the irrigation, first removing groundwater, then removing surface water for rice and wheat in India, and then I'll complement this with global estimates on what is lost. I'll do this with 3 scenarios. Imagine for the moment that India is as follows. India rice production, let's say half of it is solely precipitation fed, half of it is groundwater, and half of it is surface water. I'll use the null sign to represent no irrigation. In the first scenario, I replace groundwater with surface water, and I see still irrigating the same amount of land. How much production is lost simply by switching the irrigation source? Surface water, no. In the second scenario, I'm going to replace all the groundwater with precipitation fed. So now it's only 25% surface water. The rest is no. In the final scenario, similar to previous global analysis, we see the loss in production with nothing. For rice, simply changing the irrigation source drops production to 85% of what it is currently. Removing groundwater altogether, 80%, 75%. Without irrigation, it's predicted that rice production is 75% of what it is now. Wheat sees a different pattern. It's not so much of a drastic drop at 90%, but then it drops 60% and 50%. But this is not surprising. 99% of wheat in India is grown with less than 200 milliliters of rain. The minimum crop requirement for wheat in India is 400. So 99% of wheat in India is grown in areas with less than half of the precipitation being met. Less than half of the crop requirement being met by precipitation. So what does this look like globally? We can take these points away. So for rice, Siebert and Dahl estimated that 40% of production would be lost. They estimated that 15% of wheat would be lost. 60%.
goodness.
All right. 60% of cotton production would be maintained. And last thing, how would coffee be affected? Well, coffees aren't really irrigated, so lucky to us grad students, only 0.6% of coffee production. Cheers.